So hello, I will talk about how to deploy software with systemd-sysext and why to do it. And I will tell you what these operating system extension images are. I'm Kai Lüke, I'm one of the Flatcar Container Linux maintainers and I work at Microsoft. And Flatcar is a minimal server operating system that has image-based AB updates and a read-only user partition, but more about this later when we show some use cases for systemd-sysext. And we'll next have a closer look at the problem space and the different solutions that are there and the pros and the cons. And I will give a more general introduction about systemd-sysext and more concrete use cases on where it kind of has use scenarios that make sense from my perspective from a Flatcar Container Linux maintainer, but maybe they can serve as examples on what you could do with systemd-sysext as well. So it's about deploying software on Linux without packages. And if you think what packages give you, it's a convenient way, it's well established. They extract the different binaries for the services and CLI commands that you have, any additional required files and the config, default config that you can modify then. And you have an efficient way of managing the dependencies. And so why wouldn't you use packages? And one point is that if you have many distros, that means you have to have many packages that you create for your software. And the distros maybe have different versions of libraries that you want to depend on. And it's a lot of work to get this right. And also, having package installation means that we have some kind of state that changes. And that depends on what version was installed before, what package files it shipped, and also what the configuration that is extracted under /etc is, and whether it gets updated when you update to the new package version. And there's also some other state inside the package manager itself. And these states together can be a bit fragile when you upgrade. At least that was my experience from the last decade. And that's, I think, why some distros don't have a package manager at all in the embedded space. And also in the server space. So, for example, Flatcar has no package manager. And if we don't have packages to deploy our software, then we have a lot of alternatives. We can think about containers, for example, which are a modern change root where you have all your library dependencies inside. So of course there's Docker, container, podman, cryo, LXD containers, systemd and spawn. But in the end, they have the same result from what we look at right now. And Ubuntu also has Snap, and it's also available in some other distributions. We can also have a look at that a bit. For the desktop, we have Flatpak, and it's kind of well established there for graphical interface applications. Then systemd has portable services. These may not be that well known, I think. I will also introduce them again. And for the rest, you can also resort to having static binaries that you copy through your server and run. And it's also kind of established way, I think, of deploying software that has to be directly on the server. So, looking at containers, they reduce the dependencies on the system because they have this file system they ship, and it's kind of handy to have everything in there. And you also gain some isolation from the host to some configurable degree to protect against common cases of things that can go wrong. But this isolation and having everything in its separate file system also means we have to integrate again sometimes this container with the rest of the system. So for example, how do you start this container? You can set this restart attribute for your Docker container, but often maybe it's a better idea to have a systemd unit that spawns the Docker container with the right command line flags. And also, maybe you prefer having logging only in journal d from systemd, and have some special requirements on how the service should be started up, when, and then maybe it comes handy to have the systemd unit dependencies and so on. And yeah, so you can have this additional systemd unit file to start the container, and then tweak some kind, this isolation that you normally have to integrate it better with the system. Maybe you have some volumes that have to be available to the container and shared between the host, or there's some kind of IPC that you have to forward because it's making a service available to other programs on the system. So things like that. But what we still don't really get from deploying a container is we don't have any CLI binaries on the host that you can type in your shell, and then you have a nice command to interact with the container that kind of API it brings, or some kind of helper tools it normally would have. So for example, the container network interface plugins like Cilium, they provide extra static binaries that you copy to your host, and then you can interact with Cilium from there. And yeah, in the end, it means we need to keep track of these scattered files. Like there's a systemd unit maybe that we have. You have the additional CLI binaries when updating. Maybe you also have some config files that you have to take care of when you update the Docker image version. In Snap, we have one single file image that can contain not only the system services, but also the CLI tools. So that's kind of handy, I would say. But it's mostly only used on Ubuntu. And while available on Fedora and Debian too, it's competing with Flatpak in some way, and I don't have the highest hope that it would be the go-to in every distro for deploying your services, for example. So speaking about Flatpak, it's mainly meant for desktop applications. It has a great integration there with the portals, and you have these permissions where you can configure that the system bus or the session bus of the user session gets available, and how much it gets available to the application. So that's working well across distros, but it's not meant for system services. Maybe you can find a hack to do it, but it's not nice to do it for system services, I would say, and it's not meant to be. And what we also don't get is kind of a CLI experience. So you can set up this path, for example, and then you can type the full Flatpak name to run it, and maybe pass some commands and arguments, but it's not a nice experience. It's not meant to be used that way. And there are systemd portable services, so similar to containers, you can say. They reduce the system dependencies because everything is in its own file system tree, and you have all these isolation options available from systemd to protect the system, for example, from this service and harden it. And what you actually get is a good integration with the host, because the systemd unit files that are inside this portable service image are getting copied out to the host and then also removed there later when you don't need it anymore. And you have this own file system inside the service, and you can even layer it with some kind of extension image. So that's actually sysext, what we talk about later. But the problem we have again is that they don't make any CLI binaries available to the host. So what do? Do you add some static binaries again, or we need some way to do it together, that we have update experience where we can replace one thing and that we know, okay, the update is done now and we didn't forget any files. So static binaries are, as I said, not a bad solution often. You can use them for CLI tools, you can use them for the services as well, like, I don't know, download Caddy, run it from there. But it's difficult to keep track of all these files in the end. You have the systemd unit files, which are at a different location, then you have these binaries maybe, put them in /op/bin, and then you have additional resource files and so on, and all these need to be updated together. Yeah. And now, what is systemd-sysext? It's a way to have a file system image that gets overlay mounted on top of /usr and /opt, and you can have multiple of them stacked upon your distro's /user directory. And it's mainly meant for CLI and graphical user interface binaries for now, and there's a workaround which I will introduce shortly later. And for example, you can also, as I said, extend a portable service internal file system, or in fact, any systemd service that you start can be extended with this overlay mounts through the simple directive of using an extension image or a number of them. And then this overlay mount only happens for this service unit and not for the whole system. But its main purpose is actually to use it as overlay mount globally for the whole system. And instead of using it in addition to some kind of container or your portable service, with some small workaround, you can also ship your services as systemd-sysext. We have to kind of load these systemd unit files because the overlay mount happens too late that systemd knows about them and takes them into account. So an upstream solution would be maybe to create this overlay mount a bit earlier. Yeah, but speaking about overlay mounts, a general note is that we have to be careful to not overlay any system files in an unexpected way. So if you have the glibc library and your systemd-sysext also wants to depend on a particular version of this library, you shouldn't just overlay the host library because it has unexpected results to do so. And you shouldn't also really overlay any other binaries that are there. And it's mainly meant to extend the system. You can overlay mount stuff when really needed, but better not do it if you don't have to. And there's a way to depend on things of the host OS. For example, there's some version magic which I talk about soon. And then you can be sure, okay, this version of the OS is there. That means I can link against this minimal version of glibc then and do some dynamic linking. But if you don't really set up these dependencies for your systemd-sysext image, then it would be more a generic image. And you can also say it should be used on any distro. Then I think you should use static binaries, of course. And maybe that confused you a bit, so more in detail again from the start. So what are the allowed formats? It's a .rar file with a file system image inside. It could be, for example, squash.fs or ext4, betafs, whatever. Or it is a .rar file that has the GPT partition image inside. And so you can have, for example, multiple different variants of the sysext, and it gets auto-discovered which one should be used for your architecture. Or you can have maybe a setup with dmverity that's also supported for verification of the contents of this file, so that's not corrupted or malicious, whatever. You want to verify what you're loading there. But for simple cases, it can also be a directory, and then you put the files there, and they get overlay mounted, or betafs subvolume. So, and inside this file system tree that you have, you must have an extension release file that's under this path here called extension release dot the name of your sysext, and it's used for matching what the extension expects from the host. So what normally is there is this ID from the OS release file, where you, for example, can say ID Fedora, which means I expect to run on Fedora, and version ID is 36, the current version of Fedora, because that's what I require as minimum. Or I'm only tested with that, I'm not tested with anything newer, so only this is expected to work. And for the next systemd release, I kind of relaxed this a bit to have a way to say ID is _any. That means I opt out of version and distro matching because, for example, I just have static binaries. I expect them to run on any Linux kernel. That's reason enough. And I also don't want to have any version matching, for example. What you can do instead of this version ID also is to define your own systemd-sysext level variable. This field is free form. You can come up with what you want. In Flatcar, for example, we used 1.0 as version for the systemd-sysext level, and it just means we don't have to match the version because on Flatcar it's changing very quickly. And just say ID Flatcar is what we expect to run on. So, and this file system image is then put into one of these paths there. So the first one to look at is etc extensions, and then there are other ones. And actually the first one wins. So if you want to disable something that is in a read-only partition, which you can't take it off from there, you could just make some dummy entry in a higher order, higher priority path here and kind of mask it somehow. And then from there it gets loaded by the systemd-sysext service, or you can also use the command directly systemd-sysext merge to set up the overlay mounts, unmerge to unmount them, and then refresh to do both together. And force is actually skipping this extension release checks for ID and version and so on. So more about this matching logic. So what you have on your distro is this etc OS release file normally. And so these things are then matched together with this extension release file. So you can have strong coupling to the OS version as said, for example, for dynamic linking or some other kind of dependency. Maybe you kind of expect that apt is there or DNF or something and you want to do something with that. But I said you can also use the self-defined sysext level instead of the version to have more flexibility instead of coupling to exactly one version of it. And for example, on Arch Linux, you don't even have this version ID file. It's a rolling release. So the only thing you set on Arch Linux is actually ID is Arch, and then that's it. And you don't even need the sysext level then. And also in progress in the systemd project is what I said, making this OS ID matching optional to have _any as value in the sysext release file. And I also added architecture matching so that you can say my user space binary that I provide in this extension image are ARM64 binaries. And I expect the host to be able to run them. And there are no Semver comparisons or something like that. No semantics, it's just simple string matching for now. And it's quite new. And so I talked about having it for shipping your service files. That means they would be started up on boot or when you load this systemd-sysext image. And the workaround we have on Flatcar is this additional helper service that is run after systemd-sysext, and then it does these two commands you can see here at the bottom. It does the daemon reload to make systemd aware of the new service files that are coming in now from the overlay mount, and then we restart the common targets that you have to enable your service units. And restarting them actually just means that the dependencies are getting re-elevated. So inside your sysext image, you have a symlink that you set up from, for example, multi-user target.ones folder /usr/lib. You point to your service unit with the symlink, and then this restart here makes sure that your service gets started then. So how do you actually update these files? So you put them in this folder, for example, etc extensions, and now you want to have a new version. You can replace the single file and reload it, and live it should work, or you can also reboot if you want. But it's maybe a bit better to not just replace this file, but to have, for example, a version suffix, so that you have one folder and you store the different versions there of your extension images, and then you can roll back more easily. And you can do so by having a symlink that is the name of the sysext, and then the symlink points to the file with the version suffix, that should be the current version. Yeah, there's a fix done, so that's not backported yet and not released, so maybe the next systemd version is a bit better for that. And what you can also use is this accompanying to a systemd-sys update in 2.5.1. It's very new and has some rough edges, but you can use it for exactly this. You have some kind of local update configuration for your component that you want to update. It says what goes where when. And then you can have a remote server or some local directory with this manifest file that tells, okay, these are the versions that are there. And then suddenly there's a new version, and systemd-sys update can download this version and put it into this directory, and then also set up the current symlink for you if you want. So for example, we can let it download some new extension to this /var whatever folder we made up. And we say, okay, we store these extensions with a version suffix. And then systemd-sys update should also update the symlink here, the current symlink, to point to the new version. And it's kind of contained in one folder. And then we pull in this sysext, enable it, so to say, by having a symlink from etc extensions that points to this. So I think it's nice to have the separation of concerns with two symlinks, but you could also say systemd-sysext should directly create this normal symlink and you kind of skip this --current symlink stuff. Yeah, use cases. But maybe going back a bit, so I talked about overlay mounts, it's on top of /user and /opt, so it's not on /etc. So any files you expect to have an etc need to be somehow brought in differently. And I think you shouldn't really create them dynamically, but rather look for solutions to do it in a declarative way from /user/lib. For example, if you want to create a user account for your service, then there is a systemd way of making it at runtime without having to write an entry to etc passwd, and it gets created on the fly, and as soon as your extension is unloaded, the kernel won't know again about your service user. So always try to find a way to make it kind of self-contained, and don't write files anywhere again which would introduce the state. So some scenarios now from the Flatcar perspective. Maybe it helps again to tell what Flatcar is. It's an image-based OS, so we only release images, no packages, and we have some update payloads that also bring you to the new image. And we have AB auto updates, so it's a partition system where we have two partitions, and one is the active one, and the other new version gets written to it. And that means we can also roll back to the previous version. And this user partition is read-only. And what Flatcar also has is a declarative first boot configuration with ignition JSON files. You can also create them from some YAML, more high-level configuration language. And it is applied from the init file system. So from there, you would create your systemd-sysext and any configuration files and so on. And then the system directly boots up with them. And what Flatcar also has is a tool called Talks. And you can use it to deploy your custom Docker version. And it's meant to swap out the version that Flatcar provides it as default. And then the user can have its own version of Docker, also in some kind of image file. And instead of using Talks as a special solution, now we can use systemd-sysext for that. And it's more generic because Talks was kind of bound to Docker, and now we have something that is making these nice overlay mounts and solves a lot of trouble we had with Talks. So for users, we recommend now already to use systemd-sysext to set this up. We have some helper scripts or recipes, baking recipes in this repository here, sysext bakery, to download your official download the official Docker release binaries. These are static binaries already. And then you can just package them up by adding the systemd unit and the sysext release metadata file, and your sysext is ready. So what it does is quite simple, and you can also take it as instructions for how you can build your own sysext image. So first you have to set up the directory. For example, here it's this unpacking of the archive, and then we have to move some things around, and we create the systemd service units under the common folder, and also some configuration file for containerd. And then the last thing we do is this extension release file. Here we say it should be for Flatcar, but actually it could also be more generic. And in the end, we make a squashfs image of this because it's easy to do so. It's just one command, and it packs up everything into one file system image. If you want to have this GPT image with the modularity and so on, of course, it's more involved than that. But for starters, I think it's nice to have one single thing to do, and already you can use it. So another use case is similar again, container runtime selection. So Flatcar has this Torx software to provide some Docker plus containerd by default, but you can also disable it and bring your own. And it also had a way to switch versions. So for some time there was an old version of Docker shipped and the new one, because Kubernetes was not really compatible with the new version of Docker. And we needed a way to switch to the old version. And now we plan to use systemd-sysext for that, and you can even split this up a bit to say we have Docker in one image and containerd in the other image, and then you can have both. You can have one of them, or you can have none of them. So users could, for example, disable Docker because they don't need it from their ignition config, so the system boots without Docker, but containerd. And the way users could do this is by masking it. So currently I say could, it's not implemented. It's it's the proposal here, which I'm showing as use case. And with this empty directory instead of a dev null symlink, because that's currently the way to mask systemd-sysext that's working. Then another use case we have is cloud vendor tool updates. So in Flatcar we have the cloud vendor tools in an OEM partition. So the images that we have for Flatcar are mostly the same. They have the same /user partition, but they have different OEM partitions per cloud image type. And this is not A/B updated like the rest of the OS, and we need a solution to that. And we plan to provide systemd-sysext images instead that are stored in this OEM partition, instead of having all these files extracted there and you can't update them easily. And with some kind of migration path to delete these old files and only have the systemd-sysext images there, which are a single file, gets deleted, gets added, and you can have two of them and select the active one, for example, by some update service that downloads a new file and an early boot service that activates the one that matches our current version. And with this strong coupling to the OS version, we get also a much better integration, because on one hand, this sysext can directly appear under /usr, so no strange paths where you have this OEM mount and then inside that you have the binaries that have to be in the path. No, we have to directly under /usr bin, for example. And we can use dynamic linking more safely because it's updated together, and we have the strong coupling to the OS version. And future ideas are, for example, having some optional extensions, such as a Kubernetes extension that has the kubelet binary and the CNI binaries that you maybe want to have for container networking. And now, this could be either standalone and independent from the Flatcar version, so the user has to update it out of band on their own terms, and like Flatcar auto updates itself, and then the user decides to update the Kubernetes as wanted, and could use the systemd-sys update tool I talked about. Or maybe we could say we benefit from some strong coupling of the OS. And we also benefit from this auto-updating together with the OS. We have one reboot, and then it's a new version. And by having this strong coupling, we can say, OK, we also covered this in our release test. We know this combination is working well. And yeah, if it's not working well, we roll back the whole thing. And yeah, the user doesn't have to care about updating Kubernetes anymore then, because it's done and tested together from the OS release. Yeah, so these were the use cases. Currently, the Flatcar sysext specific docs are under this link, and they only talk about the first use case, your custom software to deploy. For example, Docker was the thing, but it could also be something else that you want to deploy. So that's working right now, and the others are yeah, work in progress. And yeah, that is the end of my talk. I thank you for listening and hope you have any questions and remarks. Would be interesting to hear about your impression now. Okay. So feel free to reach out by email if you have some questions also later. Okay, do we have a mic to share here, or how do we do it?
Do you have a few examples you can show how to build a sysext image, how to activate it on Flatcar?
Yeah, so I would have to open this website. Oops, sorry. No, I'm here. Okay. I don't have internet, sorry, I have to connect with. Okay, so assuming you build this system, the sysext image with the helper script I showed, where you have these simple commands like extract the binaries to one folder and then run, create this extension release file and then run make squashfs to build it. So you have this file then in the end. It's a squashfs image. You can mount it and look at it directly. But yeah, if you want to skip it in the beginning, you can also just create a directory under /etc/extensions and put your things in there, and then start sysext and will overlay mount this directory on top of /usr. And from Flatcar, you can do it manually. You can copy it over to your instance and run sysext, but what we normally do is we have some ignition configuration. So here it's the CLC YAML format that gets transpiled to ignition, and we say, okay, we have this sysext image maybe hosted on some server, and it should be downloaded to this path etc extensions on the first boot. And because we also don't want to use talks, because we replace the system Flatcar's Docker version, we kind of have to disable it now. Yeah, so that's what you would do from Flatcar. And yeah, I can also go to this repository maybe. Oops. Gone again. What? GitHub is blocked? Okay. Okay. If you want, I can just go back to the slide where I showed the general things that happen. Where was it? Sorry, here. Yeah, so assuming we have the path/etc/extensions, and then you create a new folder there called myExtension. Then you put some kind of file there, hello world, under the folder USR directly maybe, or USR/share, and then create this extension release file under this path inside the directory, extension release.myExtension, and then because we use a plain directory, you don't have to package it up as file system image, and reload systemd-sysext, then it would already mount the stuff. I can try to do a live demo. Not sure if it works perfectly. Okay. So I first look at etc extensions. I don't even have this. I create it first. Wrong password. Okay. Maybe. Also. So we create a extension myExt, and we also look at this systemd-sysext service. It never ran, and we will either use the service or do it manually to load it. And we will have to prepare this myExtension user lib. What was the name? I already forgot. Extension-release. And now we call our extension myExt. That means we have to create this file extension release.myExt. And the ID here is Debian, I think. Let me check. Yeah. And I don't even have a version for whatever reason. That's why I think that's enough. And yeah, we do some hello world text file directly on the USR directory. And now we run systemd-sysext, merge, and it merged this extension, so we can see with status, okay, it's there. We have one extension that overlays /USR. We can also see what is available in general, even if it's not enabled. And now the check is under /USR. We have this text file available, and it says hello world. Yeah. And now we get rid of our extension. We can unmerge it. And now it's gone again. All extensions are either merged or unmerged. And yeah, so now we remove our extension again, or we move it to some other name which is invalid because it doesn't match the extension release file. And now if we merge again, there's no extension. But there's one ignored because it doesn't have the right settings. Okay, so that's how you would use it if you try it out yourself. Does it answer your question? Okay. So yeah, any other questions in this direction or in general? Why is this even invented or something like that? Yeah, it's very new, so you can expect that it's not working perfectly maybe, but I think it has very interesting use cases. So for example, one thing that Leonard Pöttering shared in his blog post was that you could make a development version of some thing that you are working on, and now you want to test it live on your system. Normally you shouldn't do it because you corrupt your system, but if it's just an overlay mount, why not? You can reboot in the worst case and get a working system back. So yeah, that's the case of overlaying files off your system. That's not what I expect you to do in the most cases, but it's also possible. And with this --force here for the merge command, you can even skip the creation of this extension release file and it will load it anyway. So I can maybe demonstrate this. We have this invalid folder, and now we will even remove this extension file to make it even more invalid. And we will merge with force, and it now loaded this directory, created this overlay mount for us, and we see there's something called invalid now, and our file is there. Now if we run upgrade or something like that, or DNF upgrade, it will complain because we have a read-only /user now because of all these overlay mounts. So before you do any modification there, you always have to unmerge again. But yeah, normally you don't run these things directly. You can say you do it just by starting or stopping this service. So for example, we can start the service. Now our extension is merged. No, it's not because it's invalid. And I remove this file. I'm rolling release on SID, so that's why I don't have this version ID. So again, we can start the service, and now it's not there for whatever reason. Still not. Because I started already. Maybe restart. Yeah, now it's there. Okay, good. Our extension's there, and then you can stop or disable --now to get rid of it again. Yeah, so that's how you would do it. You load your new stuff in the right folders, and then you do restart, and then your extensions get restarted. And if you want to update your system the traditional way, because you don't have the way Flatcar does it, for example, or Fedora CoreOS or whatever, then you just have to make sure you disable all system extensions before you modify the user contents, because otherwise you can't. Okay, so one last question or not? Then I think that's it. Thanks.